Hello, I am Alexey Khabalov, and this is a limit order book Arena. It's an adversarial evaluation platform for market surveillance systems. It generates synthetic limit order book activity, includes controlled manipulation scenarios, detects suspicious behavior, uses AI to investigate incidents, and benchmarks different detection approaches. This project is completely synthetic and educational. It is not a trading system and it does not provide real market signals or compliance decisions. The problem is that market abuse detection is difficult engineering problem, and real market data is expensive, sensitive, and often difficult to label. Confirmed manipulation examples are rare, and surveillance teams cannot safely experiment with new attack strategies in production markets. At the same time, detector that works against one fixed scenario may fail when the behavior changes slightly. So this creates a red team versus blue team problem. The red team tries different synthetic manipulation strategies, and the blue team tries to detect them. The arena measures which detector performs best and where it fails. My goal was therefore not to build only the one spoofing detector. I wanted to build an extensive environment where market scenarios, manipulation agents, and surveillance methods can be tested repeatedly under controlled conditions. What I built. The platform contains an authoritative limit order book simulation with a matching agent, synthetic background traders, and scenario-specific agents. Normal agents create market activity, such as limit orders, cancellations, and trades. Scenario agents can inject bounded behaviors resembling spoofing, layering, quote stuffing, and other patterns. Agents don't modify the order book directly, they return bounded trading intents while the backend remains the single authoritative writer. This separation makes the simulation safer, deterministic, and easier to reproduce. So now I will start scenario from this setup, and it will be observed via different widgets on the screen, on the order book itself, on the heat map, and even timeline widget. So, and investigators in real time start to signal what happens. This explains some kind of manual mode of the platform operation. Now let's move to the Nebius Serverless usage. Here we have some control which shows local demo mode and Nebius cloud mode. You can see the cloud is now connected, and we can ping it and see that cloud is plugged to the backend. Yeah, you can see results of the AI investigation. It's a structured response, structured request, and structured response. Here we can see also disclaimers that it's totally educational prototype. Now we can move to the Nebius Command Center, which, if we are connected, we are connected, shows endpoint and statuses of our attack, investigation, and detector tournament and jobs state. So the main flow is here from 1 to 5. You can see runtime, status, deployment status, and different controls to check the cloud and refresh jobs, etc. So we also use S3 compatible storage to save results of our runs, to populate them back to the backend and to our UI. So there is scenario generator, which allows to build many scenarios, combine basic patterns together in a sequence and inject them into the normal exchange workflow, or run them as a tournament on the using Nebius Cloud. Investigation team makes investigations and records observations for the later work of the human. Here you can see results of the previous runs with explanations from the VLLM. Tournament is a simultaneous work of attackers with their invented combinations of scenarios and detectors. So we can create some benchmark, run it on the serverless environment, and grab results back. And execution trace shows scenario, detector, endpoint, job, and result. It shows what kind of runs were done before. And the third tab is about the system, explanation how Nebius is used, how to build and deploy it, system architecture, pipeline, what we evaluate, and links to papers that inspired me to create it. And again, disclaimer that it's really educational simulation. Thank you for watching.